Hello, this video is about just matrix multiplication. That's the only thing it's about. And I'm going to show you, I'm going to write a function to do matrix multiplication with simple two-dimensional arrays in processing, which is the Java programming language. So really I'm writing a Java function to do matrix multiplication. Now, if you want to know a lot more about matrices and matrix multiplications, I'll refer you to the 3 Blue 1 Brown series on linear algebra. But I also do have my own videos where I code a simple matrix library in JavaScript. But this video is in anticipation of doing some 3D graphics in 2D, so projecting a 3D shape into 2 dimensions. And so to do those tutorials, I need a function that will do matrix multiplication for me. So a matrix is a 2-dimensional table of numbers. For example, this is a matrix. And I could write, I'm gonna write 3 zeros down here just for one. No, you know what? Just for demonstration purposes, I'm gonna leave it like this, because this is actually a matrix that I'm going to use in my code itself. This is a matrix. It is 2 rows by 3 columns. Okay? Now, I'm going to show you, here's another matrix. Here is another matrix, and I'm just going to write x, y, z. This matrix is 3 rows by 1 column, right? And so one thing that's very important is that when you do matrix multiplication only works if the columns of matrix A match the rows of matrix B. And you can see those match up here. Now, what do I mean by matrix multiplication? How do we multiply these two things? Normally, when I say multiplication, I might mean something like, 2 times 3, which equals 6. Or I could even do something where, I have these two, what if I did something like 3, 1, 4, and I just said 2, 2, 1? You could almost think of multiplying these and getting a new matrix that's 3 times 2, which is 6, 1 times 2, which is 2, 4 times 1, which is 4. But that's not matrix multiplication. This is what's known, what I just did here is what's known as element-wise multiplication. It's not what I'm talking about here. What I'm talking about here is matrix multiplication also relates to something called the dot product. There's too much to talk about forever and ever in this video. I really just want a function to perform matrix multiplication with this. And what this does is basically, the way that this works is you matrix multiplication, which is, there's not really a good symbol for it, so I'm just going to write matmul right here. I want to do matrix multiplication. Let's go back to that web page that I was at the beginning. And I'm going to press multiply here. Let's see what happens. Whoa, oh my goodness, Look at that. It went up and then went sideways. That's interesting. Let's go to next. Woo, oh, look at that. So what just happened there? Look at this. I am going to take this row and multiply it by this column in a way that this number gets multiplied here, this number gets multiplied here, this number gets multiplied here, and they all get added together. So what I'm going to get is 1 times x plus 0 times y plus 0 times z. X. Now I'm going to do exactly the same thing. We can confirm this. Then we do exactly the same thing for the second row. Press this button. I'm going to take 0 times x plus 1 times y plus 0 times z, and I'm going to get y, and then I am done. So 2 by 3 matrix multiplied by a 3 by 1 matrix results in what? A 2 by 1. 2 by 1 matrix. Now, so this is the basic idea, and this is actually the reason why I'm showing you just this one scenario, is this is what's going to happen over and over again in the videos I'm about to make about taking a 3D point with an x, y, and z and projecting it into 2 dimensions. And what this matrix actually just did is just eliminate the z. It's as if I am looking straight on at a 3-dimensional object and I just can't see the z at all. Okay, so now let's go and write the code to do this matrix multiplication. So now let's open up processing, and so how am I going to make a matrix? So I'm going to call this first matrix, I'm going to make it a two-dimensional array, a projection, and I can just say, what did I say, 1, 0, 0, and I'm going to format it in my own goofy way, 0, 1, 0, and then I'm going to say float point equals, now this is silly, but I'm going to do 100, 75, 50. Okay, so let me just do this. And let me do matrix multiplication. All right. What's wrong here? I need another bracket. All right, so you can see, and I guess if I want to be consistent, I could do this. And there we go. So these are my two matrices. I have this one, and I'm just storing them as two-dimensional arrays, and I'm basically the first array, the first index is which row, and the second index is which column, okay? So that's what I've got right now. All right, first, since I'm in processing, let me just add a setup function here, because the idea is what I want to do is I want to say float result being a new matrix is something like the result of matrix multiplication between the projection and the point. Mat mul. So I need to write my own function. Of course, it's complaining at me because it doesn't know what this is. I need to write my own matrix multiplication function. So I'm going to go ahead and do that right now. And I'm going to say, this is a function that's also going to return a two-dimensional array. And it's going to take two matrices in, which are two, and then it's got to return something. So let me just add return null at the bottom here. So now I should have no errors. No errors. So this is what I want to do. I have projection, point. I want to be able to matrix multiply both of those and get the result. So how do I do that? Well, one thing as I need to do is I need to know columns A is A dot right. Okay, now how is it A dot length? And then rows A is A index 0 dot length. Does it not let me do that? Yes. Okay, so in other words, I first want to figure out the columns and rows of each one of these because that's going to be pretty important. Now, it's a two-dimensional array. So if I say index 0, the length, that's the number. Oh no, so this is the columns. This is the columns, right? The number of things in it is the number of rows, right? We can see here, like just point dot length is 3, point index 0 dot length is 1. So that's the columns of A, and now the columns and rows of B are B dot 0 dot length. Now this assumes that there's at least one thing. So an empty matrix, this is going to give us an error, but big deal. Now the other thing that I need to look at is I need to make sure that the number of columns of A matches the number of rows of B. So if columns A does not equal rows B, then I'm going to just like return null and maybe print line columns of A must match rows of B. Okay, so now we have a little, and then now, assuming that everything's okay, I can now say float result is a new array with the number of, this is so hard, the number of rows of A and the number of columns of B. The number of rows of A and the number of columns of B. There's a great comment in the chat. Why would they be float? I'm pretty sure dot length is an int. Yes, these should be integers. There's no reason to make them a float. In fact, it's only going to cause me problems. I'm just so used to programming in JavaScript where I don't have to worry about this stuff. And so to me, float is like var, let, that sort of thing. But great point, or const. Okay, so that's a really great point. So what I need to do, first of all, is I need to fill every single spot of the resulting matrix. So I need to go through all of the rows. And then I need to go through all of the columns. Whoops, result. Oh, wait. Yeah, result. This is silly because I could just use rows A's and columns B, but I'm going to, oh, these don't have, sorry. I need to go through all of the rows, which is rows A, and all of the columns, which is columns B. Sorry. I was imagining like in my previous, and this is 4, I made this matrix library. So this could be the beginnings of a matrix library, potentially, if you wanted to write your own. Have fun. Have at it. Oh, I'm like Sisyphus, and I just program the same stuff over and over again, and I make the same, and then I get all the way up to the top, and my matrix thing works, and then the matrix multiplication rolls all the way down to the bottom of the hill. I forget how it works completely and have to like push it all the way back up to the top again. This is my life. All right, so now what I need to do is now do that dot product. The reason why I say dot product is really, what this is it's the dot product of these 3 numbers with these 3 numbers. So I need to take row from one and the row and the column here. Okay, so what I'm going to do is, so the dot product needs a sum. So I'm going to say sum is 0. Then I need to go through all of the columns again. I guess I'll call this K. Columns B. And then I need to add up. What do I need to add? I need to add I need to add this, which is in position, well, it's in position 0, 0, but that's really position IK, I think, plus A, I, K times B, K, J. Does that make sense? Right? Because I'm going through all the columns of B, all the rows of A, and then K is just moving me along all the columns of A and all the rows of B, right? This is, so I'm going to go through, I'm in row I, and I'm in column J, and then I'm going to take K, which from row I times, from column I times row J. Oh, are you watching this? I'm so sorry for you. This is right, though. I actually think I have this right, but basically, let me actually make this more clear. This is row I, column K. And so when row I is 0, K is the thing going up. This is row K is the thing going up, column J, which is fixed here, just 0. So look at that. This should be what I have here. I want to multiply, add all those things together, and guess what? You might have to pause this video and make sense of this yourself. I should have practiced this. The result, I, comma j, is that sum. So now, I should be able to say return result. This is, by the way, what happens when you don't have NumPy. Your life becomes, I'm sure there's plenty of matrix libraries for Java. I just can't bring myself to use them. All right, first let's just run this and see if I get any errors. So no errors came up. That's good. I want to write a function. I'm going to call it log matrix, or let's call it print matrix. Oh, that's already a function in processing, actually. Oh, it's just so great. We get to show that later. Oh, this is so exciting. Okay, I'm just going to call it log matrix, and it's going to get matrix M. And then first I'm just going to get the columns and rows, and then I'm going to print line columns, by, oh no, rows by columns. Then I am going to print line some nonsense. And then I'm going to say, I'm going to do this nice little loop again, this double loop. And this is rows, and this is columns. And I'm going to say print matrix row column plus a space. And then when I get to the end, I'll do print line. And now what I should be able to do is I should be able to say, to test if this works, I should be able to say log matrix projection, log matrix point, log matrix result. So now let's see if anything I did work correctly. All right, let's look. Oh, no, it's wrong. Well, I'm gotten close. So, okay. Oh, first of all, let's do an extra, I need an extra print line in my log function. Let's do when it's done, let's do an extra print line. Okay, let me run this again. So I have some mistakes. So the good news is this is right, 2 by 3. This is a 2 by 3 matrix, and that looks right. This is a 3 by 1 matrix. 3 rows, 1 column, that looks right. And the result should be a 2 by 1 matrix, 7550. Now, not 7550, I'd use different numbers. It should be 175. That's what I should see, right? 175, x, y. So something is wrong in my matrix math calculation. So let's look at this. Okay, I found my bug. This right here, this is the bug. This is the offending line of code, columns B. Why is that wrong? That is wrong. That is most definitely wrong. Let's go over and look as to why it's wrong. Remember how I was saying K is counting through each column here and then counting through each row here. That's the whole thing that has to be equal. 3 columns, 3 rows. 3 columns, 3 rows. So that number could either be columns A or rows B. Either one of those things. Is that what I put in there? No. So this should be columns A. It could be rows B. That would also work. And I am now going to run this again. And voila! We performed matrix multiplication. Now I need one more helper function. If you will bear with me. What I need now also, I'm going to need this for the future. In these videos that I'm intending to make, I need a function, because I'm going to use p vectors a lot. So a p vector, by the way, like p vector v, is typically how I'm going to want to represent a point. So if I want to represent a point, I don't want to have to write it like this all the time in my code. That's going to be a major pain. But if I want to do matrix multiplication, I'm going to want some tool to convert from a point to a p vector to a matrix. So I want a function vec to matrix that receives a p vector. And then I want a function, probably also matrix to vec that receives a matrix M. So let's write both these functions. So this should be pretty easy. I just want to create a matrix which is, it has 3 rows and 1 column. And then, I'm going to be really lazy about this. I'm going to say m0, 0 equals v dot x. And then, 1, I can't type, 1 and 2, v dot y, v dot z. That's useful. And then I just say return m. Then I'm going to write the other function here now, which is, I'm going to say p vector v is a new p vector. And and v dot x equals m. What am I saying here? Which is m 0, 0. V dot y equals m 1, 0. Now, I might get some matrices back that don't have that many rows. So only if m dot length is greater than 2, then I can say v dot z equals m to index 0 and return v. So assuming these helper functions are written correctly, now I don't need this. I'm going to take this out, and I'm going to say, where's setup? I'm going to say float point equals vec to matrix v. Now I can do that. Then I also want to say, just to be sure, I'm going to say, I'm going to say, now I'm also going to say p vector v equals matrix to vec result, and then print line v also. Okay, let's run this now, and we should see, what do we got? So I have my 2 by 3 matrix. My vector got, so I really, just to be clear about this, I should probably say right up here also print line v. So just to see that everything worked. This is my p vector, 175, 50. This is my projection matrix. This is my p vector converted to a 3 by 1 matrix. This down here is the result of the matrix multiplication as a vector. And this down here is that same result. All of this to just take the z component out. But, oh boy, we're ready now. We're going to have rotation matrices. I'm ready. I'm ready to move from the first dimension to the second dimension. Oh, one more thing. Suggestion from Kelly in the chat. In terms of making a useful helper function, it would be really nice for this here to be, right, the first thing that's passed in, the second thing is the vector. So, so I should have an option where this is a vector, and then I would just say, I could just quickly, this is overloading the function. I'm writing a same version of function, but with a different argument. This is how this is done in Java. I would say vec to matrix B, and then I would say return mat mul a m. Right? So if I do that, then now I can get rid of this line, and I can just say v here, and I should have the same result. I'm going to get rid of this log. I don't think I need these logs anymore, just to make sure it works. Yep. So that worked. We can see that worked as well. So this makes our life a little bit easier. Now, again, this is by no means comprehensive in terms of matrix mathematics, but I happen to know that for the next video I'm going to make, where I'm going to take 3D points and project them into 2D, this is all that I need. Okay, see you in the next video, which I will link to through the magic of the linking of the things.